Hello, everyone. My name is Paul LaChapelle. I'm the Director of Product Management here at Juniper. I'm responsible for Juniper's service provider Edge Solutions. In my session today, we'll look at and explore what's new in broadband subscriber services and investigate some of the broadband evolutions that are happening. All right, so a bit on some of the predictions and some of the broadband trends that we're seeing. If we look at some of these trends, some of these are trying to project what to expect over the next decade. The internet bandwidth growth has been increasing 50% year over year with no change. So this bandwidth consumption on a per subscriber basis, will continue. It has been tracked by the Nielsen Norman Group since 1983. One of the main drivers for this growth on the internet is video and consumers' insatiable appetite for downloading videos over the internet. Nielsen Group has been tracking this since 1983, and pretty much this has been the same story. So major driver, major trend, and it's pretty consistent. The next one is around video and how video is dominating majority of the internet bandwidth today. You see that 60% of the internet traffic is now video. And a matter of fact, with new technologies like 4K and eventually 8K video data streams, analysts are predicting this to move up to 80% in the even within this decade. So just as an example, a 4K video stream consumes about 20 megabits per second, which is 3 to 5 times greater bandwidth compared to a 1080p HD video stream. So gaming is another interesting application. Gaming continues to be one of the top 10 highest bandwidth consumers on the internet. Gaming is consistently moving towards a digital streaming platform and is being unicast streamed from the cloud. Folks like Google, platforms like Google Stadia and PlayStation Now are a couple of examples of those platforms. But to get the full experience of these gaming applications in 4K video, you need a 35 megabit per second connection. So this is, a pretty high-speed connection in order to get the full experience, the gaming experience. So this can become a challenge for some of our service provider customers in that some of these bandwidth spikes when new gaming titles are released or patches are made. Many of the subscribers download these new titles all kind of at the same time, so you get lots of burstiness on your network, and that's something that needs to be managed. The next kind of trend area we'll look at is what's going on in the access. So access technologies continue to increase. So you're looking at fiber technologies like 10 gig PON or G.fast, where these technologies will enable higher last mile broadband connections. So today, you hear about 1 gigabit per second broadband connection services. Now these will go to, as predicted, the analysts are saying it will go to 2 to 5 gigabits per second here over the next few years. Kind of another interesting prediction coming from the FCC here in the U.S. that during this decade we should start seeing internet service being provided by low Earth orbit satellites. So you have folks like Starlink's project funded by Elon Musk. You have other folks like Amazon and the OneWeb service. All these are looking to take advantage of low Earth orbit satellites in order to deliver internet services. There are two use cases that are being discussed. First use case is around a low latency, high-end data service, and the second one is about delivering high-speed internet service for the underserved and hard to reach. Finally, the last kind of trend that we're seeing here is, related to the COVID-19 pandemic that's happening. Who would have been able to predict that? What's happening is because of the shelter-in-place phenomenon, more and more traffic is hitting service provider infrastructure networks, and the busy hour time, which used to be somewhere around 4 hours of busy hour time a day, has increased to about 18-hour busy hour a day, putting more stress on service provider networks and longer bandwidth spikes in the network. So this can be challenging to manage. Who knows whether this is going to be the new norm or things really just settle back more to what it used to be. All right, broadband. Let's take a look at the broadband evolution and what's going on for broadband networks. So today, service providers are challenged with keeping pace of infrastructure upgrades, and they want to change the way that they design, build, and operate their network. They want to ensure lowest total cost of ownership and maximum agility. So some of these evolutions that are happening in the network are around architecture evolution. So what you'll see is what used to be delivered as integrated broadband network gateway functions are now moving towards a more diversified broadband solution that includes new architectures like CUPS or fixed wireless access as a new access technology, convergence, and multi-service edge. So these shifting architectures are driving certain technologies. These technologies include virtualization of functions and taking advantage of cloud-based operations through automation. So these are becoming key ingredients to new network build-outs as you look forward. Distribution is another trend that's been going on for quite some time, moving the broadband network gateway closer to the subscriber, moving that edge closer to the subscriber in order to distribute bandwidth in a more optimized way, deliver bandwidth more optimally, as well as improve on the latency of certain applications. Disaggregation is yet another trend going on. So this is a new architecture coming out that we'll talk more about. It's called CUPS, Control User Plane Separation. The mobile core today leverages CUPS for its edge gateways today, virtual EPC, etc. The wireline networks are now starting to look at leveraging the same CUPS concept onto their wireline network. And we'll talk a bit more about that. Finally, we have convergence, wireless wireline convergence, and more on that in a little bit. So at the end of the day, the net result is that the broadband network gateway solution is evolving and diversifying in order to address some of these new network architectures and designs. So what does, just double clicking a bit on this, on these architecture shifts, again, as I mentioned, the broadband network function is pushing closer to the subscriber. So what used to be an integrated BNG running in a POP location, more centralized, is being pushed deep into metro and basically central office locations. So the drivers for this, bandwidth, latency, local caching, internet peering are all pushing closer to the subscriber. This turns into more locations, and the network is changing here in terms of delivering, looking more like a cloud type network where an IP fabric is getting deployed, small leaf spine fabric, and smaller form factor products, fixed form factor user planes are getting connected to this fabric. Talk about a little bit more on BNG CUPS. As I mentioned, BNG CUPS is defined as a user plane and control plane separation, where the user plane is running, continues to run on some distributed platform, could be a virtual platform, could be a physical platform, and the control plane function is virtualized and decoupled from the hardware. So the CUPS controller is responsible for orchestrating BNG services for all of the user plane, the downstream user planes that it's managing. So some of the benefits that are offered by the BNG CUPS architecture include operational efficiencies through a cloud-native control plane, which can manage n number of downstream user planes, flexible control planes that can scale out in a cloud-native environment, and also offers failure resiliency and recovery, a single control plane interface. So that control plane that's managing many BNG user planes is the single interface to the BSS OSS of the operator. So you don't have, as you look to distribute functions in the network, you don't have an explosion of load on your BSS network because you're aggregating that by a single control plane. And then lastly, there are a number of new use cases that you can take advantage of in a CUPS architecture that are not easily supported in a BNG integrated type architecture. And the reason for this is you have a shared centralized subscriber session database, which stores subscriber state information. So by having that shared database for n number of user planes, you get to support new and interesting use cases like dynamic subscriber service steering and load balancing, user plane high availability, centralized cloud-driven address pool management, for a whole network of BNG user planes, to name a few. All right, now we will shift to something we refer to as the next generation cloud CO. So this next generation cloud CO is basically applying some cloud principles, cloud design principles by pushing functions closer to the subscriber, by introducing a new IP fabric, small leaf spine fabric in a very distributed location in the metro, deep into the metro or at a CO location, and connecting virtual and physical functions into that cloud CO fabric. So this new CO redesign, tends to require smaller form factor products, smaller boxes, compared to large modular chassis that traditionally would be deployed in these locations. All right, ultimately, all these changes that are being made in the broadband network are intended to improve service agility and streamline operations. And in order to do that, some of the flexibility that's offered from like dynamic service steering of subscriber traffic within the network enables a service provider to optimize on a number of different fronts. Some of them, can be economic, performance, user experience, just to name a few. So having that flexibility lets you take advantage and optimize in a number of different ways. As the service provider builds out this new edge location, they have many assets that they can leverage and capitalize on. They have beachfront property locations to deliver services to end users in their central offices. They have existing billing relationship with millions of subscribers, and they have control over the quality of experience and SLAs. They have control over security, applying security services, and they have access to lots of analytics data from the infrastructure. So, our service provider customers are well positioned to deliver and capitalize on new services, but there'll always be that level of co-opetition with the cloud companies as they look to, kind of encroach on this space by developing new edge cloud capabilities as well. So Google Anthos, Microsoft Azure, AWS Outpost being examples of that. Okay, let's step back a little bit here and look at broadband evolution in the context of wireless wireline convergence. The top half of the picture is showing kind of how the mobile architectures have evolved over the years, and on the bottom shows how the wireline network architectures have evolved over the years. And in the orange on the right side shows you a converged mobile core. If you look at the top on the upper left, that network architecture shows you, some of the network elements where the P gateway and the S gateway functions are integrated as control and user plane running on the same network element. The next generation of that looks to introduce CUPS, where the control plane is separated from the user plane, and you can see the S gateway U and the P gateway U there. Similarly, on the wireline side, the same trends are happening. BNG has traditionally been deployed as an integrated network element. If you move to the right, you'll see now this year and into next, BNGs will start being deployed as CUPS in a CUPS architecture with separated control and user plane. And then, fast forward onto wireless wireline convergence, and you see that same BNG network element evolves into what they call an AGF user plane function in a converged architecture, and the P gateway U, S gateway U become this UPF user plane in a 5G converged architecture. So this is basically how wireline and mobile networks will evolve onto a common converged core network. Okay, so this slide tries to wrap it up and show you some of the key investment areas that Juniper is making around the broadband subscriber services space. It shows kind of a combination of roadmap and strategy. So first, on the bandwidth side, we continue to deliver probably the most robust portfolio in the industry, showing small, compact, very powerful, high capacity routers that are supported in distributed architectures, and then the larger modular systems that will end up being 400 gig optimized BNGs of the future. We're also cloudifying basically our network architectures. This cloudification involves disaggregation of control plane from user plane, so that's leveraging virtualization technologies and cloud native control plane. We're also introducing support for these new cloud CO design architectures, as well as introducing automated cloud-driven address pool management for networks of broadband network gateways. And finally, lastly, is around convergence. Juniper's strategy here is to leverage the huge install base that we have across our service provider customers of MX using custom silicon. We have this MX hardware that will deliver a hardware-assisted high-performance user plane for mobile type architectures. And this is intended to kind of provide an offload function for high bandwidth users on the converged mobile architecture. And you see a number of different development areas, including the UPF, AGF, as well as the important building on top of the BNGs to allow seamless migration from wireline network to a converged mobile core. I just wanted to thank you for listening. Appreciate the time to present to you today, and please enjoy the next session.